Okay, so exponential functions, these are the applications, so level 2. We're still going to use the same basic equation, y equals a times b to the x, to write our equations because these are exponential. A is still our starting amount, and b will be 1 plus r, or we'll solve for it as we did in our level 1s. All right, the town of Osseo had 2,974 residents in 1980. This was the town's largest population. For the next 20 years, the population fell until 2000, when the population was 2,434. Write an exponential equation to model Osseo's population. So at no point did they tell us the rate of population decline. So we have to find B ourselves. Fortunately, they did give us 2 values to use. In 1980, hey, that's our starting amount. So in 1980, they had 2,974 residents. So since that's our starting amount, we're going to call that 1980 year 0, which will pair with 2,974. And in 2000, 20 years later, the population was 2,434. So instead of worrying about 2000, let's just put year 20 and then 2,434. So we're going to treat this the same way we've done our equation writing in the past. Our A is our y value paired up when x equals 0, and then we need an x and a y to solve for B. So 2,434 equals 2,974 times B, we don't know, to the 20th. Okay, so we'll divide by 2,974. Which is 0.818. And that equals B to the 20th. Okay, and then we use the correct type of root to get rid of the exponent, which is going to be a 20th root. Okay, so we'll do the x root in our calculator. Remember, you do 20 first, and then you find your x root symbol. And then you do the 0.818. And you get 0.99. So B equals 0.99. So the exponential model is y equals 2,974 times 0.99 to the x. All right, so part B, which I started writing into the space for, what is the rate of decline during this time period? So if we know that B equals 1 plus R, and we just got 0.99 for B, then we can solve for R. We'll have to subtract 1. So negative 0.01 equals R. Multiplied by 100 there, that'll be 1%. Since it's negative, we know it's a decline or a decrease. Okay, let's try another one. You earn $9.50 per hour and have been promised 1.5% raise every year. Right? An exponential model to equation to model your hourly wage. Okay, this one's a lot more straightforward. We have our starting earnings right here at $9.50, so that's going to be our A. And we have a rate right here, 1.5%. What we have to worry about, though, is that to find B, we have to do 1 plus the rate, and we have to remember to write the rate as a decimal. So we have to do the opposite of what we have been doing. We have been multiplying by 100 to turn a decimal into a percent. we're going to have to divide by 100 here to turn our percent into a decimal. So that's going to be 1 plus 0.015. So our equation will just be a matter of filling that in. Y equals $9.50 times 1 plus 0.015, so 1.015 to the x. If you continue working this job for all 4 years of college, what will your hourly wage be then? Oh, okay. So now we know our number of time periods is 4, so we just need to substitute 4 in for x and use a calculator to evaluate. Remember to press your exponent key between the parenthesis and the 4. That's a very common mistake. And you get $10.08. So not a very big wage increase for you. Perhaps you want to interview for different jobs. Okay, and one more example. Lamar bought a home security system for $12,500. The value of the system decreases 3% per year. Write an exponential equation to model the system's value. Okay, so very similar to the last one. We know how much Lamar paid for his system, so that's his starting amount. There's our A. And we know that the system decreases 3% per year. So that 3% is R if we can just change it to a decimal. So divide that by 100. R will be 0.03. Okay, the other thing important to notice in the setup for this is decreases. So that means that rate is going to be negative. So when we fill that into our equation, we need that negative. So y equals 12,500, the starting value. And then instead of 1 plus r, well, it can be 1 plus r. It'll be negative, though, 0.03 to the x. X being time periods, which since it said per year, x is the number of years. So you can simplify that. You don't have to write that with plus and negative. That would be 12,500 times, you could have 1 subtract 0.03, or you could actually type it into your calculator. That would be 0.97. Looks really nice. And then to answer the question, after 5 years, we just need to put 5 in for x. So in a calculator, we would type 12,500 times 1 minus 0.03 or 0.97, whichever way you have it written, exponent 5. Remember your exponent key in your calculator. Okay, and after 5 years, the value of the system is down to $10,734. And since it's money, I'll round to 2 decimal places. So it's 17532. So I'll round that up to 18 since there's a 5 behind the 7. Okay, as always, ask questions in class if you have them.